Hey, this is Math 7, Unit 8, Lesson 5, More Estimating Probabilities. So, beginning off here, we have question that says, is it likely? So, what do you think? If the weather forecast calls for a 20% chance of light rain tomorrow, would you say that it is likely to rain tomorrow? So when we're talking about if it's likely or not, we're deciding whether it's closer to, in this case, we usually say with a decimal or fraction 0 to 1. If we're talking about percentages, we're talking about the difference between 0% and 100%. So 20% is kind of down over here. So we would probably say that it is not really likely to rain tomorrow. That's a pretty small chance, but it could, right? So we can't rule it out. It's not impossible, but it's not likely, but it could. In terms of the next one, if the probability of a tornado is 1 out of 10 or 1/10 tomorrow, would you say there will likely be a tornado today? So 1/10 as a probability, or as a decimal version of looking at it, is 0.10, which again is even less than the 20%. It'd be like over here. So we would also say this is not likely to happen, but again, it could, right? Not saying that it can't, just likely that most likely it will not. If the probability of snow this week is 0.85, would you say that it's likely to snow? 0.85 is more over here on our little scale. So we would say that it is likely. So yes, it is likely to happen, but it might not, right? We don't know for sure. There's always a chance that it wouldn't. It's not 100%, but it's more likely than not likely. So we would say yes, it's likely to happen there. All right, for this next activity, we have to kind of go through a little process here, playing with some spinners. If you're at school, your teacher might give you a spinner, or they might have you use the online spinner and practice that at home on your own or at school. So if you use the QR code right here with your phone, you can just use your app, your camera app, and it'll open that up, or you can get a QR reader and it'll go to a spinner that looks like this. And there are actually 6 spinners, or 4 spinners, spinner A, B, C, and D. And we're going to use that for the next activity. It says spin your spinner 10 times and record your outcomes. Okay, so there's going to be 4 different spinners. So in your class, you're going to have different groups, right? You're going to have a group what's going to have spinner A, spinner B, spinner C, spinner D. So let's do like this. We're going to say that spinner A, we'll go like this. We're going to go with the numbers 1, 2, 3, 4, 5, and 6. Okay, those are our different numbers we can choose from here. And we have spinner A, B, C, and D. So we're going to make a little chart here as we go through these spinners, because they all have, actually they have more than 6, don't they? I forgot about that. So the first one has 1 to 6 as outcomes. The second one is 1 to 6. Oops. Let's see, our other one here, this goes 1 to 12, so I got to go 7, 8, 9, 10, 11, 12 actually, all the way out there for spinner C. Make my chart a little bit longer there. And then spinner D actually just goes to 4. So D, we don't even have to worry about these options. Doesn't exist. And then A and B, we don't do 7, 8, 9, 10, so those don't exist there. Okay, so already we can see that in terms of a sample space, A and B have the same sample space, 1 to 6, 1 to 6. C has the most possible numbers, and D has only 4 possibilities. So what we're going to do real quick is we're going to spin these and just get some scores or some marks here of what it comes up with. So I'm going to spin spin letter A. Alright, see if we have it there. I think we can see it for the most part. And here we go. I think we're set to go there. Alright, so I'll press the spin button for A. So we spin it, and we end up with a 4. So that's 1. Do it again. We have another 4. That's 2. Spin it again. And we have a 3. Spin it again. And we have a 2. Spin it again. And again, you can do this on your own. You can fast forward this part, whatever works for you. I just want to get some data here for you as you might do it in class. So as you're doing it along with me, you keep your own chart if you like. whatever makes sense to you, but you want to record your data so you can use this here. And keep on going. So 2 is right there. Okay. And so we've done 5. We've done 9. One more time to go. And we end up with a 3. So there's my 10 spins right there for spinner number letter A. We go up to spinner B. We have 1 to 6 once again, so we spin it and start it off. Okay, that's 1 spin. 2 spins. 3 spins. I think that's on a 3. Can't really tell. I'm going to spin it again. I can't really tell where it's at. It's on the line almost. I know, they don't line on the line, but I'm going to make it clear. It's 4 spins, 5 spins, 6 spins, 7 spins. Can't tell. 8 spins. 9 spins. And 10 spins. Interesting. Look here. We didn't get any 1s, did we? But if you look at it, there's only one possibility for 1, so it makes sense of why we didn't get a lot of 1s. Let's go to spinner C, where we have all the numbers 1 through 12. We're going to do it 10 times. Ooh, a slow spinner. Way to go. Great. Lands on a line. Try it again. 3. That's 1. 2. Oh, slow motion. 3. 4. 5. 6. 7. 8. And on the green, 9, and one more, slow motion, 10. And the 1. And our last one here, this one's a little different. We have a lot of space for 1, and then 2 and 4, and then 3 is about 1/4 of it, right? So this is just split apart. So 1/4, and there are 4 numbers, but that's about 1/4, and maybe about less than 1/4 there, 12%, 12%, and that's half right there. Oh, sorry, 25% right here. Yeah, so 12 and 12. Let's see what we come up with. 4 choices. Hey, we got a 1. Spin it again. Hey, we got a 1. Are you surprised so far? I'm not too surprised. There's a lot more space for the 1, isn't there? You think it has a better chance of winning? Well, let's keep going. Hey, there's a 2. So that's 4 so far. There's 5. 6. 7. 8. 9. And finally 10. Alright, great. Okay, so we spun them all. Did you get all the different possible outcomes in your 10 spins? So we can see here for the A spinner we did not get 6. The B spinner we did not get 1. Nope. The C spinner we did not get 6, 7, or 10. And for D we got them all. So did we get them for all of them? We would say yes for D only. Again, I'm doing all of them. If you're only doing one spinner, your answer might be different. That's okay if you just had the A or the B or C or D. So we didn't get them all for A, B, or C. C would be the toughest one to get, wouldn't it? If you only have 10 spins, how could you get all 12? It's just not really possible, is it? Okay. So what fraction of your 10 spins landed on 3? Well, let's look at each one just so we can see all of them here. For A, we had 2 out of 10. For B, we had 2 out of 10. C, we had 1 out of 10. And D, we also had 2 out of 10. Okay? So those were our outcomes for A, B, C, and D. So we have them here. So we have 210, 210, 110, 210. So 2, 10, 2 out of 10, 1 out of 10, and 2 out of 10. Now, do any of the spinners have the same sample space? Sample space means same possibilities. All right, and we looked at that when we started. So if that means they're the same possibilities, that's the first thing. We would say in our case here, yes, A and B had the same sample space, right? So A and B had same sample space. But are the probabilities the same? Well, let's take a look at A and B. Okay, scrolling down here. So with A, for A, we have all the numbers, and there's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So every number is on there the same number of times. Every number has a 2 out of 12 opportunity to get chosen. So that's it for A. When you look at B, you have 1, 1, 2 2s, 1, 3. Wait, so B's a little messed up, right? So here's 1, 2, 3, 4, 5, and 6. And we have only one of the ones. We have 1, 2, 3 2s. We have 1, 3. We have 1, 2, 3 4s. We have, on the 5 side, we have only one 5. And the 6s, there are 3 5s. Okay, so we have a lot more 2s, 4s, and 6s on spinner B. So the probability is the same? No, the probabilities are different for what we can see here. So for example, like you look at the number 2. For number 2, in A, the probability for number 2 is 2 out of 12. But for B, the probability is 3 out of 12 because there are more of them there, aren't there? Okay, so the probabilities are a little different for those two spinners. For each spinner, what is the probability that lands on the number 3? So let's take a look here at each one for the number 3. So for the first one, oops, gotta slide down there. We have 2 out of the whole 12. So we have 2 out of 12 for A. For B, we can see that there's 1 out of 12. So it's 1/12 for B. For spinner C, we have 1 there out of 12, so also 1/12. And then for D, the 3 is there, and we can see that it's 1 out of the 4 parts. Now, it just so happens that this size is about 1/4 because the 1 is definitely bigger. But in terms of sample spaces, it's 1 out of 4, and in terms of the overall probability, because the way the sizes work out, that actually is 1/4 of the size of the spinner. So the probability of getting a 3 is different for A and D, but definitely the same also for B and C. For each spinner, what's the probability that lands on something other than a 3? Well, other than a 3 is going to be all the other choices. So if we can get 2 out of 12 or 3, that means that there are 10 out of 12 that are not 3s. For B, if 1 out of 12 is a 3, that means there are 11 out of 12 that are not 3s. Same for C. And for D, if 1 out of 4 is a 3, that means 3 out of 4 are not 3s. Okay, so that becomes how that works out for the spinner stuff. Okay, so let's look what the next one is, still with the spinners. It says that Noah put spinner D on top of his closed binder, and he spun it 10 times and it never landed on the number 1. Remember, spinner D was the one that looks like this, right? Half of it is a 1, and then you had this and this for 2, 3, and 4. So how in the world could you spin that and never get a 1? Well, again, explain why it could happen. If you've looked at binders before with a 3-ring binder, it looks a little bit like this when it's sitting on your desk, doesn't it? One side is like that, and then the other side tends to fold down like so, with your little papers in between, right? So if the spinner is sitting up on top of here, and the 1 is over here, and the 2, 3, and 4 are on this side, and you spin that guy around, just because of gravity, that spinner might tend to go downhill most of the time and not give you with any 1s. That's a possibility. Who knows? Hard to say. Han put spinner C on the floor and spun it 10 times. It never landed on the number 3. So he says the probability of getting 3 is 0. Well, 0 means that's a never can happen. It's an impossible just can't happen. But the reality is that there is 3 out of 12 possibilities. And as long as there's one, if he kept going on, eventually something would happen. Now it's a small probability, right? If you look at what is 1 divided by 12, that's a 0.083, or about 8% chance of getting the number 3. It's really small, but it still is possible. All right, so there's that one. Activity 3. It says your teacher's going to give you a bag of blocks that are different colors. Do not look in the bag or take out more than one block at a time. Repeat the steps until everyone the group has about 4 turns. So we're going to do this about 12 times. And what I'm going to do is I'm going to take a bag here, just like before. I'm going to put it 1, 2, 3, 5, 6, 7, 8, 9, 10. Put the stuff in the bag. Okay, so in this bag, which is right here, I have some blocks. So what I'm going to do is I'm going to reach in my hand, and I'm going to grab out a block and put it back in and try it again. So let's see what we get here. We have green and other colors. So let's just take a look. We have green and we have other. We're going to do 12 times. So reach in, pull out a green. So that's one try. Put it back in, mix them up, pull out another one. I get another green. So that's 2. Put it back in, mix them up, and pull out another green. That's 3. Put it back in, mix them up. Hey, I got a white. There's that one there. Put it back in, mix them up, and I got a green. That is 5 tries. Put it back in, mix it up. I got a white. So that's 6 tries. Halfway there. Mix them up. Got a green. So we're 5 for 7. Mix them up. Got a white. It's 5 for 8. Mix them up. Got another white. So 5 for 4. Oops, pencil broke. 5 out of 5 for 9, I should say. Mix them up. Got a green. There is. We're at 10 so far. 2 more to go. Got a green. So it's 7, 4, and 1 more. Got another green. All right. So we have 8 green and 4 other. In this case here we had white is what we did when we drew them out. Now you might have had something different. That's okay. So what do you think the probability of taking out a green block from the bag is going to be? Now in this case here it seems to be we did 8 out of 12. Now 8 out of 12, if you reduce that fraction, 4 goes in here 2 times, 4 goes in here 3 times, so we're at 2/3. That's about 0.66. Is about the probability of getting a green in from what we experiment with. Now, is that going to be accurate every time? Hard to say. Okay, how can we get a better estimate is the second question without opening up the bag. Okay, well, right now our estimate is we did 12 times, the experiment 12 times, and we got 0.66. So how do you get a better estimate? Do it more, right? The more times you do it, the better that estimate's going to be. Well, let's take a look at what's actually in that bag and see what should we have done. When we dump it out, well, what do we have? We had 3 green ones and 2 white ones. So the reality is that we had 3 out of 5 were green. So as a probability there, that's 0.60. Okay, so our estimate is maybe a little high. So if anything, the more we did this, we might get a couple more whites to bring that down just a little bit. But boy, that's pretty close to what we would expect with our predictions there. All right, so in summary, you can look at things like if you have a bag that has blocks, if you select a block at random from the bag, then the probability of getting one of the blocks is 1 out of 5, right? So any block, 1 out of 5. If you have a bag like this and said, well, what's the probability of getting a star? You'd have 1 star out of 1, 2, 3, 4, 5 there. But this bag, you'd have a chance of getting 3 out of the 5. So sometimes it depends on what is in the bag. It depends on how many there are in the bag for what the probability is going to be. Okay? So different experiments can have the same sample space, but they can have different probabilities. In this case here, the sample spaces are the same. Star, moon. But because they have differences of what's in the bag, you end up with a different probability. So it is important to know what is inside those bags in order to get the right probability. All right, we're going to pause there, let you work on your homework, and then come and check it together in just a few minutes. Here we go, homework for Math 7, Unit 8, Lesson 5. What is the same about these two experiments? What is different? So we have selecting a letter at random from the word Alabama and a letter at random from the word lamb. Okay, so they're both random. That's the same thing there. Let's take a look at our sample space. So for our sample space, in Alabama you have the letter A, you have the letter L, the letter B, and the letter M. The A just happens to come up there. The A is in there 1, 2, 3, 4 times, right? In lamb, you have an L, you have an A, you have an M, and you have a B, and everything is 1 time. Okay, so what's the same is the sample space is the same. What is different is that this one has more A's than any other letters. So it's going to have more of a probability of getting an A than another letter because you have 1, 2, 3, 4. You have a 4 and 9 chance, right? No, 4 and 7 chance, sorry. 4 and 7 chance of getting an A there, where here you'd only have a 1 in 4 chance of drawing an A. So that sample space, while it's the same, because there's different amounts of them there, that is going to change your probability. All right, number 2. Andre picks a block out of a bag 60 times and notes 43 of them are green. What should Andre estimate for the probability of picking out a green block from the bag? Well, if he did it 60 times, we could estimate that it's about 43 out of 60 based upon what he's done. We don't have any other information. We just know he did 43 out of 60, so that's our estimate for the probability. Now May looks in the bag and sees there are only 6 blocks in the whole bag. Should Andre change his estimate based on this information? We would say yes, he really should. And the reason for that is this is like thinking about a bag that has 60 in it and you picked out 43 green of the 60. This number on the bottom, once you know what that is, that becomes your numerator. So in this case here, we want to have some number out of 6 is what we're looking for the number of greens. So when we take a look at what he did, he had 43 out of 60. So this is pretty close to being about 40. So we're going to estimate this maybe at about 40 out of 60. And you can reduce that down. And so you end up with something about 4 out of 6. So 4, 6 is probably a really good estimate for how many greens he would expect to get if he took them out of the bag. If there were only 6 in the bag altogether, 4 of them are probably greens. So it'd probably look something like this, right? It'd be a bag that had something like that in there, where you had 4 greens and maybe 2 yellow. And if you did this 60 times, you might get 43 of these, and the rest would be yellow. Again, that's just what you might get. Number 3. A person suspects a standard number cube is not so standard. That means it's coming up the same number again and again and again. Something is a little fishy with it. He rolls it 100 times and it lands on the number 6, 40 times. Another person rolls it 100 times and it lands on 6, 42 times. A third person rolls it 100 times and it lands on 6, 33 times. Based on the result, is there evidence to help prove the cube is not standard? Explain your reasoning. Well, how many options are there on a number cube? You have a 1, a 2, a 3, a 4, right? A 5 and a 6. So you have 1, 2, 3, 4, 5, 6 on a number cube. For it to come up as a 6, that is a 1 out of 6 chance of it coming up as a 6. Now 1/6 as a decimal is 0.16. So think of it this way. That means that if I rolled it about 100 times, I should expect about 16 out of 100 is what I should expect to see if I did this again and again. So for someone to get 40, and then 42, and then 33, those are far greater than the 16 I should see. So the evidence would show me that for 3 different people to roll it 100 times and get these results, something is wrong because I should be much closer to 16 than I am to 40. That's a little off there. All right, so that's something to think about there. That's it. Number 4. A textbook has 428 pages. They're numbered in order starting with 1. You flip to a random page in the book in a way that's equally likely to stop any pages. So you're flipping around with 420 pages. What is a sample space of this experiment? So what are all the possibilities for this experiment? Well, 1, 2, 3, dot, 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 427, 428, and that's my sample space. So any number between 1 and 428. I hope you didn't write out all 428 of them. That would be quite a lot. What's the probability that you turn to page 45? Exactly that page, only one of them exists. Only one of those pages exists out of 428. So that is the probability. One page out of 428. What's the probability that you turn to an even number page? Well, even numbers can be about half of them. So 428 divided by 2 is actually 214. So you could say there's about 214 even out of 428, or you could have just said, like we said out loud, it's about half of them. All right, last one here. A rectangular prism is cut along a diagonal on each face to create 2 triangular prisms. The distance between A and B is 5 inches. Let's take a look at this prism here. All right, so here we go. So this length right here is 5 inches. Got it. So what is the surface area of the original prism? And then what's the total surface area of the 2 rectangular prisms? So for the original prism, we have this side here, this 5 by 4 side, and it's on this front and it's on the back side. So we have 5 by 4, which is 20, and we do that front and back for a total of 40. We have the bottom, which is a 5 by 3, but the bottom is the same as the top, 5 by 3. So we do 5 by 3, which is 15, times 2 to make top and bottom, and that's 30. And then we also have the front side, which is here. This is the 4 as well. We have a 4 by 3. So 4 by 3, and this in the back over there, which is 12. Multiply that by 2, so we are at 24. So the surface area of the original prism is this added up together, and we're going to be sitting here at 94. The question then is, what about the surface area when you change by slicing it in half? Well, now you're adding this little shape right here, and it's kind of hard to see, right? It's going to be from here to here to here to here, and it's on both sides, right? You're slicing it there, and that becomes the new bottom. So think of it this way, like that goes away, and that back part goes away, and you just have this triangular prism. So for this triangular prism, we want to find out what is the area of that square right there. Well, that square, it told us in the question that this diagonal part was 5, which means that's a straight edge there, and this part is already 5. So we have 5 times 5, which is 25. Okay, that's the area of one, but there's 2 of these now since you cut it, so we add another one, so we actually have 50. So when we put those together, a 94 and a 50 becomes 144 inches squared. This is inches squared there. So the 2 prisms is 144. The one rectangular one is 94. All right, that's it for today. Have a great day, and we will see you next time.